Right. As everyone's entering today, we want to welcome you to the RITIS user group web meeting. We're very happy that you took some time today to hear about some great uses of the RITIS and PDA suite tools. Okay. As folks are entering the room, I'm just going to take a moment to walk through the housekeeping. Many of you are regulars and we appreciate that, but just to give you a reminder, this meeting is being run in Zoom webinar, and you can use, for your audio, you can either use your computer or your phone. This web meeting is being recorded. If you have any questions about the audio or the web, please reach out to Esther. We'll give you, we'll talk about the Q&A in just a moment. Here we go. So you can ask your questions today using the Q&A box. Just simply type in your responses, and we will either, the presenters or folks from CATT Lab will either answer them in the Q&A box or verbally. If you would like to ask a question verbally, you are welcome to do so. You just simply raise your hand and that will bring you to the top of the list, and we'll let us know that you have a question. And then when we get to the appropriate point in the presentation, we will unmute your line. At this point, I'm very excited to turn it over to Nicole Forrest. She is the TSMO Program Associate for the Eastern Transportation Coalition. Nicole?
Good afternoon. Thank you, Joanna. Welcome, everyone, to our RITIS user group meeting. I thank you for taking the time to join us. So we have some upcoming RITIS events that we would like you to note down on your calendars. February 25th, we have our RITIS workshop using the probe data analytics for congestion management process reports. And then our next RITIS user group web meeting will be May 1st. So notate those dates on your calendar. And thank you for that. And it's my pleasure to introduce Matt Glasser. He is the National TSMO Account Lead with Arcadis. In his role, Matt assists agencies with developing and enhancing performance management, strategic plans, and technology deployments. Before he joined Arcadis, Matt worked at the Georgia Department of Transportation in the Office of Traffic Operations, where he worked in arterial and interstate operations. And Matt obtained his Bachelor of Science in Civil Engineering from Georgia Tech and is registered professional engineer. So over to you, Matt.
Appreciate that, Nicole. Thanks for that lovely introduction. And Joanne, I think we can go ahead and move on to the next slide. Get rid of my face. We have an incredible turnout today. We were just running through the numbers. We have over 346 folks registered. I already see 157 that have joined. From those 346, we have 111 unique agencies. It seems like every single one of these sessions keeps getting bigger and bigger, certainly not just from the agencies in the states that you see here, but from the consulting firms and universities attached to help support those state and local agencies. So certainly a huge welcome to everyone. We're happy to have you, and we hope that this session is beneficial for you. On to the next slide, please. So with today, we have a packed agenda. Of course, right now we're doing our welcome and introductions. After that will be Franz running through an overview of the new PDA Suites analytics for the energy module and the associated methodologies attached to it. Greg Jordan will be talking to us about using probe and trip data analytics for the LA fires. Rick Ayers will be talking to us about using the PDA for identifying areas of excessive speeding. Bob Frey from MassDOT will talk to us about the RITIS Enhancement Working Group and what's coming out of that with Michael Pack. And then we'll wrap on up with our user feedback session, any questions that haven't been answered along the way. And certainly, again, just want to make sure that we're hearing from this group of users about things that we can always make better within the platform. We can go on to the next one. And let me walk through our speakers for today. I already did a brief introduction, but let me give you some quick bios. If you haven't heard of Michael Pack is a director of the CATT lab at the University of Maryland, where he works to make transportation data more easily accessible and usable by operators, planners, and researchers. He has previously worked at the University of Virginia and the Oak Ridge National Laboratory. Mark Franz earned his BA in physics and BS in astronomy from the University of Florida, his master's from West Virginia University, and his PhD in civil and environmental engineering from the University of Maryland. That PhD had an emphasis in transportation engineering. Greg Jordan is the feature manager of CATT Lab's trip analytics toolset. Prior to joining the CATT Lab, Greg managed a helicopter survey company that conducted 80 origin, destination, and routing surveys using aerial video to trace vehicles. He also used the helicopter results to validate the use of NRIC's trip path data sets for origin destination surveys. Greg has drawn from these experiences to design new capabilities and features within trip analytics. Rick Ayers has over 30 years of experience working for location-based enterprise software systems at the federal, state, and local levels. In his current role, he serves to support state and local transportation agencies in the successful implementation and deployment of RITIS. Rick also worked extensively with the Eastern Transportation Coalition member agencies, as well as federal and state transportation agencies, to support and manage their respective enterprise implementation of RITIS. And lastly is Bob Frey from the Massachusetts Department of Transportation. Bob has worked in a variety of roles in MassDOT's planning office for more than 2 decades. Most recently, one of his focus areas has been vehicle probe data and GPS data, as he manages MassDOT's RITIS contract and has participated in various coalition meetings for the last several years. So first up, we're going to give you a little bit of get those brains exercising and get an idea of who you are and how you use RITIS. So 3 polls. First one, how often do you attend the RITIS user group meetings? 1 to 2 times per year, 3 to 4 times per year, or this is your first meeting. Second one, how do you use the data and visualization results from RITIS tools? Do you use those results directly from RITIS to develop products? Do you download the data and use your own agency's in-house tools to create tables and visualizations, or we do a little bit of both? And lastly, who is your primary audience for sharing information that was developed from RITIS and the PDA suite? Is it peers? Is it your management, your executive leadership, elected officials, or the general public? We'll leave that open here for a few more seconds until it starts slowing down. And Joanna, I'll let you do a countdown when you start seeing everything slowing up.
Oh, damn. Got some more people. We'll give them a couple more seconds. Oh, another little group. All right. So we're going to close the polls in 3, 2, 1. And we'll share those results.
All right. So up first, looks like a bit of a almost an even split in terms of folks that are attending. For the 28% of you that this is your first meeting, we hope that you enjoy it and hope that we'll see you come back in May for our next one. Second poll, how to use the data and visualizations. And certainly C keeps creeping further and further up. I think that number keeps getting bigger every single time that we do this poll, doing a little bit of both in-house visualizations and using RITIS directly. And then the primary audience, top one continues to be peers, but certainly seeing more growth with our executive leadership and elected officials. So definitely appreciate your feedback on that front. So with this, we have incredible spotlight presentations today, and I definitely encourage everyone to be hanging around for all of these. Of course, we want you to be here all the way to the end so that we can get your feedback. But to be sure, with each one of these are definitely very new looks at how folks and individuals are using these tools to really change the way that they are operating, planning, and managing their systems. So with that, again, definitely encourage everyone to hang around all the way through. It's going to be a great show. I think we have our next one up, and Mark, let's kick it off with you to talk about the energy analytics.
Thank you, Matt, for the introduction, and thank you everyone for your interest in our presentations today. I'll be talking about the overview of our new tools, and our data analytics will become available to our PDA users tomorrow. Talk a little bit more about that at the end. So I'll go ahead and jump into it. So just a heads up, I'll be jumping in and out of this PowerPoint, giving some live demos of the tools, so you all can follow along. So a little bit of background on this tool and what our motivation was to get it out. We actually built an initial version of these tools for a Department of Energy project that was called the Transportation Energy Analytics Dashboard, TEAD. And at that time, we had partnered with MWCOG in Columbus, Ohio, to build out these tools. So until today, those were the only two regions that were able to access these tools. But we saw the benefit in opening this up to other RITIS members. So that's our motivation for getting this out. So just taking a look at some of the statistics that motivate the need to measure and monitor energy use and emissions is that the transportation sector is the largest sector in terms of contributing to greenhouse gas emissions in the United States at 28%. That's even more than the power companies or the power distribution grid. Many state and local agencies already are and have been monitoring energy use and emissions. Oftentimes, this is done with what's considered the gold standard, the EPA MOVES model, so the Motor Vehicle Emissions Simulator tool, which has been updated a couple of times since its first launch. So the only issue with the MOVES model is that it requires a significant amount of effort and expertise to run it. There's, I think, 40 or so different inputs that go into the model, and it takes some time to run that model, and the outputs are CSV files. So even that output needs some work to generate the performance measures and data visualization. So we saw the opportunity to help streamline that process with a new set of tools. So what's included in our tools? We tried to boil down the inputs to some basic inputs that most agencies already have or are collecting on their own or getting from third-party data providers. So the three inputs that are required for these tools are the TMC probe vehicle speeds, the TMC conflated traffic volumes, and vehicle registrations. We use the vehicle registrations to make inferences on the engine type and the traffic stream, and we support the analysis of gas, diesel, hybrid, plug-in hybrid electric, PHEV, and fully electric vehicles. Each of our tools produces outputs that give estimations on the energy use in several emissions parameters. So those are energy use itself is in the units of BTUs, and then each of the emissions parameters are in the units of tons, and they include carbon dioxide, carbon monoxide, particulate matter 2.5, nitrous oxide, volatile organic compounds, otherwise known as VOC, and hydrocarbons. A few things to take note of. We tried our best to do some validation of our the energy use component of our models using field measured energy use from a previous DOE project that recorded fuel consumption using OBM sensors. And our outputs are generally within 10 to 15% of those field measurements. It's also worth noting that energy use from electric vehicles is not currently included in our outputs, and that commercial vehicles are also not included in our outputs as well. The reason is we're working on developing some methodologies to handle that and better data on what types, not only the percentage of commercial vehicles, but what specific types. A tractor trailer has a different profile than a box moving truck, for example. So those are things that we're working on, but they're not quite integrated into the model yet. So this is a framework of how the tool works. So on the left side are basically what we ingest and the data needs. So I already mentioned the probe speed, the vehicle registration, and traffic volumes. We also use the TMC segment metadata base. So the length and the number of lanes are inputs into our model. And then we have some other parameters that we derive from the MOVES 3 model, including the emission rates and fuel economy data that ultimately drive the estimations that are generated in our outputs. I'll mention here that CATT Lab has provided nationwide vehicle registration data that's aggregated at the zip code level for the years of 2017 through 2022, and those are currently available in the tool. We're in the process of procuring 2023 and 2024 data and hope to have that up in the next month or so, depending on how the procurement process goes through. I'll also have a reminder here to encourage our agency partners to submit their own registration and volume data. We have some volume data in there, but the more frequently it's updated from you all, the better the results will be. And it goes beyond just the energy and emissions tools. We use volume data and a lot of different tools in probe data analytics, including the user delay cost tool and the causes of congestion tool. So giving that one set of data feeds a lot of different tools and functions in our tools. So we encourage you to update that as frequently as you can. So we take all that input data, we apply our models to it, we've used different data sources, and then we have the outputs that are available in 4 different tools, which I'll give a demo of each of these tools independently. So we have the vehicle ownership chart tool, which basically only uses the vehicle registration data and shows the trends in the change in vehicle types adoption rates in a given zip code. We also have the energy use and emissions matrix, which allows us to look at the energy use and emissions parameters by day, hour of day, and day of week for the date range that's selected. We have a trend map, which plays like a movie where you can play either one date or multiple dates to show the difference or before and after study. And then energy use and emissions charts, which breaks down energy use and emissions by road class, hour of day, day of week. I'll walk through each of those. So I'll jump out of my presentation for a moment and pull up my browser. So again, these tools will become available in Probe Data Analytics for you all tomorrow at 11 Eastern time is what we're aiming for. So keep an eye out for that. You can find them on the PDA landing page. So this is a growing list of tools that we have. But right here is vehicle ownership charts, the energy use and emissions matrix, the trend map, and the emissions charts. And I'll go through a demo of each one. I'll start with the vehicle ownership charts. And because the data is aggregated at the zip code level, users can come in and enter the list of zip codes that they're interested in looking. For this example, I picked a zip code in near Portland, Oregon, in the downtown area. And you have the option of selecting the years that you want to include in your output. As I mentioned, we have the data in our system currently from 2017 through 2022, 23 and 24 will be coming shortly. So once you enter that information and confirm that this is the geography that you want, the zip code that you want to analyze, you go ahead and hit submit, and then you'll get an output that looks like this. I'll zoom in a bit. So within this map, you can see that it breaks down the vehicle registrations by engine class. So we have gas, plug-in hybrid electric, diesel, and then we have one for other. This is more of a catch bin in case we can't determine exactly what the engine type is. Sometimes you get odd vehicle registrations, so that's sort of what that's showing. But you'll notice that here in Portland, you see this trend of gasoline little by little going down each year, which is, for air quality considerations, that's what you'd like to see. Plug-in hybrid electric gradually increasing. The same thing with hybrid and fully electric. You also have the option, because you'll note that when you do this, and not surprisingly, gasoline tends to dominate the vehicle registrations. And so if you wanted to turn gasoline off and look at the other kind of lower number of registrations, you get more details. So the scaling looks a little bit more discernible. You can see the differences in those. So you can do this for any of the engine types if you want to turn them off and turn them back on. You can also change colors. If you don't like this one, you can go to pink. And so a lot of different ways that you can use the data. And so this is sort of a static tool that's using the vehicle registrations just to look at general trends and vehicle adoption rates. Our next tool is the energy use and emissions matrix. So this is very similar to the rest of our PDA tools. So I won't go through in detail how to do the road and date selection, but you come in, select the roads that you're interested in running your query on. Then you have your time period to analyze. So I'm looking at the month of April in 2024. And then you select your data provider. So here I'm using Pennsylvania is the primary data source that I'm using. And because the Pennsylvania and New Jersey are INRIX users, I also have access to the INRIX 2029 data. That's the most recent volume data that I have, in case you're wondering why I'm using 2019 volumes in the year of 2024. Again, I encourage agencies to submit their volume data. In any case, those are the ones that we'll use for the analysis. I'll go ahead and hit submit. And then after a few minutes, it'll run the numbers and generate this output. So it's a matrix that has the breakdown of the various energy use and emissions parameters by hour of day. And each day in the date range, it breaks it down by hour. And at the end, you have the grand total. So within this tool, you can, again, look at specific engine types and pick those if you want. I'm going to leave it at all for right now, but you do have the option for selecting individual engine types. And you can select through all of the output parameters. So you have energy use is the default that you get, but you can also switch it to any of the other emissions parameters, so CO2 emissions, and you'll see that update accordingly. Users also have the ability, as they always have in our PDA tools, to change the color schema. So if you wanted to move the threshold for the lowest bin and push that to the left, you can do that, and the map will update automatically. If you want to switch back to what the defaults were, you just hit the refresh button and everything will update. As with our tools, you can also download this data as an Excel file using the Save button up here so that you can develop your own visualizations and export the data behind what's in this matrix. The next tool is the energy use and emissions charts tool. So again, you select the road segments and time period that you want. In this case, I've selected several road segments in the downtown Atlanta region, and I'm looking at the date range for the month of October 2024. And so we look at the output of that. We see that the output shows the data in a couple of different ways. So again, you can switch between the various energy use and emissions performance measures. Then you have the breakdown of this by, and I'm showing here day of the week, but we can switch it to road class, where we can see the contributions of interchanges, interstates, and others. This table on the right provides some useful information about the road mileage that's included in each of the road classes, as well as the energy use and the vehicle miles traveled. The last column shows a very useful metric, I think. So it kind of normalizes the results. So if we were to only look at the interstates, they will be, by far one of the higher ones with parkways in terms of the number of BTUs that are being used. But then when we normalize it by the vehicle miles traveled, we can see that these numbers all come within 4.3 to 4.9 or so. One of these would stand out. You would see that maybe because this is 4.9 BTUs versus a little bit lower ones, that we're running a little bit less efficiently on the interstates on this particular segments of roads. You can also look at this as a pie chart if you want, and then you have the ability to look at the relationship between various metrics. So here you can look at the energy use versus VMT by road class. And so we'll show the matrix, and you can hover over any one of the points to get the details on what's on the X and Y axis. So you can change these if you want to look at NOx emissions, if you want to change VMT to energy use and its relationship to NOx emissions. It's very flexible. And again, you can also export this data that's behind the visualizations in the table in an Excel file by clicking the Save button. The last tool that I'll show is a trend map. So again, you select the roads and the date ranges that you're interested in. In this case, I selected a northbound segment on I-270, which is just outside of the Washington, D.C. region. In this particular case, I looked at two different dates. The week before Thanksgiving, Wednesday, which was November 20th, 2024, and then the Wednesday just one day before the Thanksgiving holiday, which was November 27th of 2024. And you go ahead and hit the submit button, and you get an output page that looks like this. So on the left side is the November 20th. So this is the week before Thanksgiving. and then Wednesday the week before Thanksgiving, and the right side is the Wednesday just before Thanksgiving. So I'll go ahead and press the animation button, and it'll step through the performance of, in this case, it's showing energy use by hour. So you'll see that things look normal, and then it starts to get worse as mid-afternoon comes through, and we start to see darker shades of red indicating more energy use going on. And then by midnight, or I'm sorry, by the PM peak, things start to settle back down. And this was, reflective of what people did on the Wednesday before Thanksgiving. So a lot of congestion built up, starting in the morning through the early afternoon, people trying to get out of town ahead of the traffic, and we saw the increase in energy use accordingly. You can also output this information, so you can look at things such as screenshots. You have the XML file that's behind it, a GIF, a movie, or you can take individual images of each hour so that you can include that in any reports or media outlets that you're trying to disseminate this information through. One thing to note with this tool is we're able to look at the individual segment level outputs. So we can look for this hour what the energy use was on this particular segment. But also keep in mind that oftentimes with this type of analysis, we look at the aggregate over all of the segments. So this box up in the top shows the summation of the energy use normalized by the VMT for this particular hour. And you can see the increase here. So it's about 75 K BTUs per VMT in this hour versus 68. And that's at the noon hour. So different ways that you can break down the data and analyze it. This particular one, I think, is really unique because it allows users to look at individual road segments, which I think is a new concept for a lot of folks. We're usually looking at energy use and emissions at a large scale, like either at the planning organization scale or for an entire year, or at least a county for an entire year. So we're hoping to get some feedback on, if you find this is useful for helping to investigate air quality and energy use in your analyses. So I'll just wrap with one last comment in my PowerPoint slide. So just to summarize what we went through so far, there's 4 new tools that were going to be launched tomorrow around 11 a.m. Eastern time. So for those that are full RITIS members and access to the PDA suite, this will become available to you. We made it possible by procuring the vehicle registration data, and we'll be getting 2023 and 2024 soon. When we launch this tomorrow, there are some limitations on the parameters that you can request. So you can initially, for now, you can request up to 5,000 TMCs for up to 1 month. But in upcoming months, we're going to be scaling that up so that you can do queries for like an entire state for the whole year. So that will be coming soon. We're hoping that you'll find that these tools streamline the process for estimating energy use and emissions, especially for those that are using tools like the EPA MOVES model. We're ingesting this data, we're pre-processing it, and you can request these outputs with a few clicks of a mouse. So interested in getting your all's feedback once you start experimenting with that. I already talked about the future enhancements with the enhancing the query parameters to do a whole state for a year. And we'll also are pursuing another energy use output. That would be the gallons of fuel, both diesel and gasoline, that's being consumed rather than just the BTUs. And one last reminder to submit your updated vehicle and volume data to our intake at ritis.org. And if you have questions about the format for either of those, you can reach out to support. We have templates that we can share with you and with sample data in it so that you all can follow that format and send us your own vehicle registration data. And that concludes my presentation. Happy to take questions if we have time, or I can open up the chat box and do it while Greg presents.
Yeah, we really appreciate that, Mark. That was a wonderful presentation. I think we'll go ahead and hop right into Greg's presentation. So as folks have their questions, please go ahead and drop them into the Q&A box, and we'll work our way through those. And there we go.
Thank you, Matt. And is my screen showing up okay?
It is, yes.
Okay, and thank you, Mark. That's really interesting to see how that's coming along too. I'm going to take about 20 or 25 minutes talking about the LA Palisades fire. And if you weren't paying close attention to it, I wasn't at the time, and now I know a whole lot more about it. So I will share that with you as well. So just as a starter, headlines, torches 1,000 structures. Well, that was after the first day, and that's before they really counted them. It's actually, this particular fire is up to 7,000 structures that were torched. It started at 10:30 in the morning on a Tuesday. Within 24 hours, virtually this whole area of the Pacific Palisades was ravaged by the fires, and I'll walk you through those. The big picture is that at the start of January this year, there were 5 that were going on at about the same time. And the driving force were these Santa Ana winds, which are the up in Utah and Nevada, literally a large weather pattern. And what's interesting to note on these fires is that they're all on the downstream side of mountains. And that is something that these winds come through. Normally they're 30 or 40 miles per hour, but when they get through the canyons of the mountains and they come back down, they accelerate. And you'll even get 50, 60, 70, 80 mile an hour winds that just blow for the best part of several days or longer. So that's kind of the background of what we're dealing with. But really, the Pacific Palisades are where so many people from, essentially wealthy people from Los Angeles buy in here. And I say wealthy from that's one of the nice places to go, but the developments are they're densely populated, but a very popular place to be. And these are the 3 main areas. Several factors really added to it. No rain since March. In other words, 8, 9 months straight without rain. Prior to that, there were 2 years of a lot of rain, which meant a lot of vegetation built up, and then it turned brown. So that was problem number 1. We already talked about the winds, problem number 2. And this on the left is a picture of the first moments of the fire as some camera detected it out there for CAL FIRE. And the timestamp at bottom right corner shows about 10:34 in the morning. And this is what it looked like 4.5 hours later. And that's what driving the wind is doing. And I want to point out this one spot down here. We'll talk in a little while about you can actually see Sunset Boulevard going across there. And then you also have a road down from the summit. There's a major intersection there. And look how the fire, in 4.5 hours, the fire is basically attacking that particular crucial intersection, for evacuation. By 6 o'clock on the same day, you had the fire coming down the canyon in the middle of the neighborhoods, and it was spreading. By the next morning, I haven't found a really good source to show, but most of this had been inundated by the next morning. Ultimately, this is how far it reached out. So let's just focus a little more about the evacuation challenges here. These are all in the Palisades, which means they're on hills, steep hills between mountains to the north and ocean to the south. So you've already got a problem. But look at the red lines here. These are natural barriers of which there's no roads crossing them. So depending on where you live, you are limited on where you can go to get out. And you tend to basically have these routes. You got to get out on one of these routes or multiple of these routes. In this case, because the fire was coming into the west, it wasn't really a safe evacuation to the west, but to the east, it was to get over to Santa Monica. That's where safety was. So each of these are potential bottlenecks. And as we mentioned before, this one Palisades Drive, you can really see it here. The community to the north, 1,300 homes, and they all evacuate with just one way. There is a fire road over here, but I have no indication that was used for anybody to evacuate. So if you saw pictures of bulldozers pushing cars off the road, it was on southbound Palisades Drive or westbound on Sunset Boulevard coming into that bottleneck. So probe data analytics, we'll just mention a couple of tools. We started off with Trend Map. Whenever I do an analysis, this is my favorite starting tool. Mark just described the tool. I'm not going to go into it, except that with Mark's, it was showing the tool has been expanded to show emissions information. This is basically speed-related calculations. So the metric we're going to use is the congestion metric. We're using colors, and the user gets to set these colors, just as Mark demonstrated. But for example, if your measured speed is 30 miles an hour and the free flow speed is 65 miles per hour, that's a 46%. And that would be in orange based on this color scheme. So if you look at the map in the upper right, you can see the various colors. And these are this is what we are measuring right here. And you also have a box that pops up. You can actually hover over any colored segment, and an information box will come up to you and say, free flow speed, 37 miles an hour. Measured speed, 9 miles an hour. And I set this one up to represent 12 o'clock to 1 o'clock p.m. So that's what we're going to start with to look at it. The best thing I think of the trend map is that I can pick the time I want to look at with the slider across the bottom. I also can do the split screen like Mark was showing, where we put a normal day on the left, which we went back to Tuesday, December 3rd to get ahead of Christmas, and then January 7th. So this is the format. And if I go up, and I'm looking here at 10:30 in the morning on the normal day, and I see what normal patterns are, and we verified that this is normal. And oh, by the way, when the fire started, it looks about identical. If you go back and forth between these maps, they're going to look virtually identical. So we had a normal day when the fire hit. That was at 10:30. 30 minutes later, we have our first indication of slowed down or fire-affected traffic. And within 45 minutes, we're seeing reds along. This is Sunset Boulevard. It starts down by the ocean and comes across, and then it gets down here. At this juncture, evacuees can head down and over, or they can head up, down, around, and over. But that's the critical route. And even the satellite photos, you can pick out this road. And then the canyon, Temescal Canyon Road, goes right down the middle of it, and that's an important part of it as well. So we can hover over any spot, and it shows you for that time period. I'm using 15-minute intervals for these, but I'm just going to click around very quickly and just show 11 miles an hour southbound here at that particular time. If you were in the housing looking up the hill, this is what you see coming. I did a lot of YouTube video checks when I was looking for ground control. Congestion getting out on Sunset Boulevard, Pacific Coast Highway, cutting up to Santa Monica. At 3:15, we've got basically the data went gray, and gray usually means there's no flow or a closed highway. So I decided to come in and look at that, especially because of that intersection we talked about before that I thought was going to be a real bottleneck. Here's what the time-lapse map looks like, and I'm just zooming in to look. This is a Google Maps a view of it, but the big intersection is right here, and the big red arrows are the flows, the evacuation flows trying to get out to the Pacific Coast Highway. And what I did is I did some video hunting, and I came across this evacuation story that somebody basically picked up his elderly father who had Parkinson's disease, and right at this direction, this blue arrow, that's where this is located. They've got fire on both sides of the road, and police officers are telling everybody, get out of your cars. All 4 lanes, 2 lanes each way, no, all 4 lanes were congested trying to get out, and nobody was going anywhere. And then this video shows this Parkinson's diseased elderly person trying to be coaxed out of the car and walking down. It's just quite the nightmare that you can't appreciate unless you really spend some time with some of these videos. I also found a video showing the defense of this Spruzzo restaurant and bar, and I went to look up and see what that looked like. So with Street View, I've got this view. Look at the hill behind it. That's the avenue for the fire to come down. And that's what's happening. So here was a kind of, and by the way, this restaurant was protected and saved. This is right down the street. You can see the restaurant in the distance. And here's another video that shows how this was happening. Note the palm tree catching fire. One of the interesting things I saw, and I witnessed this because I had a neighbor's house burned down here about 10 years ago, and I got to watch it. These things about embers blowing in these high winds are not big chunks from your fireplace. These are invisible accumulation of little hot things that just spontaneously ignite things. And you're actually, all these firefighters are up and down the road. It's not like a forest fire is going to run over and burn everybody. It's simply this way the fire spreads with the wind. It's almost invisible as it jumps from place to place. So let's look at these travel times. The first thing we looked at, and by the way, I forgot to acknowledge my two colleagues, Mark Franz and Sarah Sahidian. This is the work of three of us. And we've done a lot of work on this. And the one thing Sarah is an expert at is taking the massive data, the raw data, because we wanted some raw data controls. And these are all the corridors that she ran travel time, very detailed travel time analyses on. So let's just look at one of them. Sunset Boulevard east of the Canyon Road. This was that major evacuation route to the east. And notice that Monday is a normal day. Tuesday, the day of the incident, we can see that traffic was normal right up till 11 o'clock. And then 12 o'clock, 1 o'clock, 2 o'clock, we had the impact of people, the travel times trying to get out of the area. Another one to look at is the Temescal Canyon Road coming southbound. And you've got, if you look northbound, we've got pretty much normal traffic both ways. Not a lot of delays in the northbound direction, which makes sense because that's into the fire. In the other direction, we see our very sharp spike between about 11 o'clock and 3 o'clock in the afternoon. If we look at this, it's basically 7 minutes travel time to go about a mile. It comes out to about 8.5 miles an hour. And if we recall, our blurb said for this time period, we had 9 miles an hour. So that's a nice correlation between the two of them. But what I'd like to do is get a little more precise about those travel times. So INRIX volunteered to send us real-world trips, a sampling of real-world trips quickly so that we could get this analysis going. We can snap those to pathways and get routes and evacuations. So what we're seeing is the trip analytics route map showing the evacuation of almost 400 vehicles between noon and 3 o'clock in the afternoon. And again, this is a sample of all trips. What we can do to get travel times is we can make a study area that we put a boundary around it, and then we can trim away anything that's not inside the study area. So when we get travel times, it's like getting floating cars through the study area from one end to the other. So if we're trying to test southbound Temescal Canyon Road, we can make a study area that's going to trim away any part of a trip that's not inside the study area. Then once we've done that, we can put, we're seeing here two purple spatial filters. The from has any trip that moved inside the canyon on the canyon road. That's the first polygon. The to polygon is at the south end for the Pacific Coast Highway. We want to capture trips with pathways that hit the from first, and then it hit the to second. So it's a way to reach into the database and pull out just the trips that we want. And again, we're not going to get a lot of trips each hour, but we're going to get enough for floating car runs. See this. Floating car runs, we basically have 9 miles an hour as our number one. We had, in the course of this 1 hour, we had 4 floating car runs that are basically 9 miles an hour. But the fastest one was 1 minute, which was going pretty much full speed, and the longest one was 12 minutes. So we have quite a range there. If I want more detail in here, those are all rounded values. I can export the table, and we can see that the length of the segment was 0.84 miles, and these are the information from the reliability is the 80th percentile or the 50th percentile. The next row down shows trips actually the segment stretched outside. So this is a longer segment. This is 1.35 miles, and you had to make your right turn to get down there. So we're down to a 4 mile an hour for those trips that did that. So altogether we had 14 speed runs coming down this road, and that's one of the ways the tools can be used to find out that kind of information. Now, more generally, you can find origins and destination and routes. And the way the tool works, it pulls out like these 373 sample trips that we found, which is only a fraction of the trips, but we make an OD matrix for those trips. We then take the same trips and put them on a zone map. And in this case, what we're showing over here, origins are inside. This is the Pacific Palisades area. So we're saying find trips that started inside these two zones and left it and ended outside the two zones. Where did they go? And that's what the zone map, it's essentially the same thing. It's the same numbers as the OD matrix. It's just a visualization. And then, of course, we talked about the route map where you actually put these trips down and you see where they went. So when we set it up, we set up polygons. The first two polygons here were on either side, the western and the eastern part of Pacific Palisades. Those are going to be the from. And then where did they go to? That's all the rest of these zones. And the farther, if I zoom out a little bit, yeah, those are the two. If I zoom out a little bit, I have bigger areas. And if I zoom way out, I've got much bigger areas. So the closer in, the more granularity that I want. So these are all loaded into the tool. So what do these OD zone maps look like? Well, we started with a spatial filter, which are the two zones I showed you. And then we kicked the checkbox. We want trips that started inside and ended outside. And then we started hour at a time, 10 in the morning to 11 in the morning. 11 to 12, 12 to 1, and continued to do that analysis. So here we are from 10 to 11, and then we go to, let's see, 11 to 12, 12 to 1. By 4 to 5, we have very few trips, sample trips leaving, and by 8 p.m. to midnight, we only showed one trip leaving. Of course, this is all the time period that the fire is moving through the area. Now, we can look at those same trips and look at their routes that they took. So we're going to turn around. Here is the route map. And, the thicker it is, the bigger the numbers are. A lot of these trips, in this case, for this hour, we found 85 trips. About half of them found a home inside Santa Monica. They ended there. Whereas the other half made it out to the screen line. I drew a screen line farther out to see the distribution. Each screen line adds to 100%. And so we can see the splits of where the traffic went from 10 to 11. And if we hit it, there's the blow up that kind of shows the breakdown. We hit it 2 hours later, and we see how our percentages change. Notice we're up to 0 now. Nobody's heading out to the west anymore. And by the very end of it, you only have a few trips, and the ones that reach the lines, they're going out to the on I-10. Now I can look at what if I redraw that screen line much tighter, and I'm going to catch many more of the vehicles. And on the left here, that is the fire day from 10 to 11. But I also inset a normal day, December 3rd, to see what that looks like. And if you look back and forth between these two maps, you're not going to see much difference. And that's kind of the nice thing about doing it now from 12 to 1. Look how much activity now is happening to get away from the fire. Still a little bit of activity to the west and to the north, but by 1 to 2, you're not getting anything up there. And by 4 to 5, you're down. A relatively few number of trips are leaving, and they're all looks like they're not taking the Canyon Road. That's been fire, and they're all working there. Most of them are working their way up out of West Sunset Boulevard. So, and 8 p.m. here, we're down to just a handful of trips later on. We found one sampled up till midnight. Okay, so now let's just look at the trips going through a particular intersection as they evacuate. And to do this, I took the same maps you were just looking at, and I clicked on the spot I care about. That turns all of the pathways blue that went through that spot. And then I dropped down to the menu and I said, only show me the blue routes. And everything else is hidden. So this mode allows me to look and analyze trips based on points that they pass through. So the key point here is we talked about Sunset Boulevard, and you have a split to go south or to go north. So I did just a sample look of how that looked. This is from 10 to 11, and this is from 1 to 2, which was kind of the peak evacuation period. And 3 to 4, you see it going down. And 5 to 6, you still have some vehicles going. So that's a way to use the time lapse. By 7 to 8, we only had one sampled vehicle crossing through that intersection, and they were going out Sunset Boulevard. So that's the analysis we have so far. This is kind of getting our feet wet, getting started. What else are we going to do? The first thing that we're going to do is go up to this filter here and say, instead of started in and out, how about we start out and end in? Let's find out about the people that were driving into the fire and what those patterns were. And I think that, we just haven't had time to do it yet, but I'm really looking forward to that. The other thing we're going to do is continue analyzing the aftermath. We have more data just delivered. So we look at the days 2 to 4. This is Wednesday morning, by the way. You still have fires. The fire is still working its way across the different areas. When we're done with that, we're going to move over to the Eaton fire, which is the other major one. My nephew's office building was at the edge of fire. They had damage, but they did not have their building destroyed. So we'll talk about that one. But then we're going to really dig into thoughts about how these can inform policy discussions and emergency planning. One of the things these tools can do is help tell the story, because planners need to get resources to do the kind of analysis that they really need to do in order to plan. Number two, the public has to understand why they're being inconvenienced by this and why they need to comply. Public announcements, agencies have to decide, what do we tell the public or order the public, and when do we submit those? And those are all things that you don't really know, but you have to think about ahead of time if you're going to handle it well. Operations planning. When you've got a bottleneck like Palisades Drive intersecting Sunset Boulevard, are there special strategies to be done? How many people, especially, a lot of us, if we've got 2 expensive cars in our garage and I've got 2 people in the house, I'm probably just instinctively going to say, honey, how about I'll take this car, you take that car? Well, now you have single occupant vehicles arriving at that bottleneck and everything stops. It would be interesting to know. These are just some of the things to look at. Innovative strategy. If a hurricane is coming, airport people with aircraft will fly them, hundreds of miles away to keep them out of a danger for the hurricane. Well, the night before this happened, the Weather Service warned about extreme fire damage and dangerous conditions if a fire breaks out. Well, do we take out our loved ones who are infirm? Do we take out our pets? Because a lot of those videos had people going back in trying to get their husband, their wife, their elderly person, their pets. The guy wanted to get his 2 dogs out. And nobody said anything about expensive cars, but I have a feeling that there was interest in getting those expensive cars. Why not move them out the night before? Well, you need to tell a story because people generally won't do it. The last thing to mention is that the whole micro simulation industry, there are people that do modeling for emergency evacuation. This can help improve and inform those models to make them better. So that is the presentation. I know I covered a lot in a short amount of time, and depending on what others have seen in the chat, are there any questions I should handle now? And you're certainly welcome to contact any one of the 3 of us, because this was really a team effort, and we will gladly walk you through the procedures or processes that we did.
Well, appreciate that, Greg. That was great. And I know that you, like you said, you burned through a whole lot real quick. We do have a couple minutes that we can take questions. If folks want to go ahead and put those in the chat right now, we'll wait a few seconds. But if not, we'll go ahead and move into our next presentation. And of course, we'll keep our eyes on the chat. All right, Greg. Well, I don't see any coming in right now, Greg. But I think, we'll probably see a few come in here in a few seconds or the next minute or 2. So with that, I think perhaps we'll just go ahead and move on to Rick. Let him move on from this, and then we'll keep monitoring the Q&A. So Rick, you're up next.
Fantastic. Thank you, Matt, and awesome job, Greg. A phenomenal example of leveraging RITIS and probe data analytics to support understanding the impact of a natural disaster on our surface transportation network. Some really interesting insights. In terms of using data to drive decisions or insights about our surface transportation system, I'm going to share with you a little today about how to leverage probe data analytics to address what is a pervasive problem across our country, and that is excessive speeding. Next slide, please. I think all of us, it doesn't really matter whether you're in an urban area, MPO, city, or you're supporting a rural part of your country, excessive speeding is an issue and challenge that transportation professionals have to deal with. I think one of the things that I hear a lot from our user community is, Rick, we're not a big community. We're not a large city or big metro area. How does probe data analytics support us in rural areas? It's this particular topic as an example use case that I think really tells and compels the use and application of probe data and probe data analytics and the RITIS software platform to support understanding where excessive speeding is taking place, but also, if you implement safety countermeasures across various different corridors, what's the efficacy been? Have we been successful in reducing excessive speeds? So we're going to talk a little bit about that, and everything that I'm sharing with you, this real world use case and example of and some analysis that I've done, where no hardware is deployed, there's no sensors. Think again, while there's terrific coverage of ITS sensors in some urbanized areas, again, these rural areas, you don't have ITS devices to detect or observe and monitor excessive speeds, let alone if you've implemented countermeasures. How do we determine if we've been successful? So I'm going to cover several PDA tools that will give you various different insights to identifying where excessive speed takes place, but also some tools that allow you to kind of evaluate countermeasures and any improvements that you hopefully made in terms of from a safety improvement perspective. Next slide. So as part of this demo or part of this use case that I've set up for you, I'm going to demo several tools from the Probe Data Analytics Suite. The underlying data for the region that I'm doing my analysis, the probe data itself is provided by NRIX within the state of Virginia. And some of these tools are going to allow us to identify general trends for speeding, but also some specific tools that I think are really useful for identifying or determining the efficacy of where safety countermeasures have maybe been implemented. And to kind of wrap up the demos and show you how I've taken some of the results and then integrated that into a GIS platform to kind of help tell the story to policymakers, decision makers with regard to that after action analysis of safety measures that have been implemented. I'm going to share my screen now. Thank you, Joanna. So the story begins in Fairfax County, which is pretty significant sized county population-wise in and around the DC region. The early part of 2023, Fairfax County Police wanted to implement a kind of a broad range or a broad regional sort of safety countermeasure program. They call it the Road Chart program. Kind of crack down on aggressive driving. For months, there's been observed excessive speeding in and around Fairfax County, particularly on specific corridors. And I'll talk a little bit about which corridor that they spent a lot of time on. They had different phases of the program. And, in March of 2023, they kind of began the rollout of this Road Chart program. In July, they kind of stepped it up again in phase 2. And interestingly, it was in July that they were still having excessive speeding issues. This is dash cam video footage of a Fairfax County police officer who pulled somebody over, unknown what the reason was. But I'm going to go ahead and play this. You can hear some of this. This is Fairfax County Parkway, eastbound lanes. Unbelievable scene. That vehicle that struck the car that was pulled over and nearly killed this Fairfax County police officer was traveling at 100 miles an hour westbound on Fairfax County Parkway. So that, that particular incident, unfortunately, was happening during this program or this campaign to communicate to the public and those who use this particular corridor and others to try to help reduce excessive speeding. Now then, using that as kind of set the stage for the story, similar to what Greg had mentioned, whenever I do any analysis with Pro Data Analytics, I want to tell a story. I use the trend map tool. It's a great way to dive into a specific corridor or a group of corridors and ask some questions about what was the general trend on this corridor or on these roadways for the period of time that I'm interested in. So for Fairfax County Parkway, I've got a number of different ways in which I can, identify the roads or the spatial parameter of my query. My new favorite way to select corridors is using the route selection tool. Now, the route selection tool basically is used much like you would define a route, maybe in a typical consumer mapping application. So you say, you know what, the route that I want to analyze, I'm going to start it here. You'll see a little blue or purple road segment get highlighted. So you know what, I'm going to take my route through here, kind of create some waypoints and extend it all the way up to just before Interstate 66 in Fairfax. Once it's completed that route, this is the route that I want to analyze. Imagine how useful that would be for creating a commuter route that you wanted to analyze. Commuting patterns don't necessarily follow, a single US route or a single state route. Commuting patterns or evacuation patterns, as Greg was demonstrating, take oftentimes very sinuous routes to get to and from any place. So now that I've added the road segment, Fairfax County Parkway, that I want to analyze, notice this really nice there's this button here for the roads that I just added that allows me to create the reverse route. So it's just going to let me go ahead and identify the segments in the reverse direction. I'll add those. And now I have in the westbound direction and the eastbound direction, the road segments that I want to analyze for the period in 2023 where they were implementing these safety countermeasures across Fairfax County, March, July, and then sort of an after action assessment, I chose November. So the results of my analysis for the trend map look like this. I've got March here in the leftmost map, July here in the center, and November. Remember, a trend map is just an animated, 15 by 15 minute kind of playback of speed or any other performance measure that you might be interested in looking at. I'm looking at speed right now. I know that on Fairfax County Parkway that the speed limit, the posted speed limit, is 50 miles per hour. So using trend map and to identify trends of to look at where and when along this trend map speeds exceeded 60 miles per hour. Now my legend up here is already pre-configured, but I can change that. I could drag and drop this. Maybe I want to look at speeds above 68, but 60 miles per hour is kind of the target for my analysis. But I want to really highlight those. So I'm going to come in here and I'm going to change that to magenta. Now watch what happens as I animate or move through my trend map from early morning until later in the morning. Look what happens. I'm immediately identifying where and when I'm seeing excessive speeding from a trend perspective in each one of these months. Now, unfortunately, we're seeing that between March and July and November, kind of after these countermeasures and these campaigns were implemented, we're still seeing some excessive speeding on certain segments. But overall, I'm going to go to late at night because that's always an issue as well. Overall, generally speaking, between March, July, November, we were seeing a decrease in excessive speeding. Remember when you're doing analysis with probe data analytics, particularly when you're mapping to these road segments, the speed data is being mapped to harmonic mean based on distance. Another way to kind of look at roadway segments, but in a graph form, is using the corridor time comparison map. So here we're just looking at a graph-based version along a linear diagram of the same corridor, same segments, but I'm just looking at it in a different perspective. So here I'm looking at March weekdays, 12 to 5 a.m. versus November. And as I look at this graph, westbound and eastbound on the right side, generally speaking, there's not a whole lot of change relative to historic average for the 12 to 5. But if I look at the 10 to midnight representation of that data, check this out. There's certain segments of that corridor that there's some pretty dramatic slowdowns relative to historic average. And in both directions. Some areas is basically the same, but really interesting way to kind of look at the data from in a different perspective in a graph form, but also look at it in context to historic averages and kind of pinpoint, hey, we had success here near Huntsman Boulevard. You could zoom in, with your scrolling with your the scroll wheel on your mouse to kind of explore those details in the corridor time comparison chart a little bit more. Another way to kind of compare and contrast the impact, were we successful, were we not, is the temporal comparison maps tool. Now, keep in mind, most probe data analytics tools, they're designed, the intent is to identify where there's congestion. So this is a really cool way to kind of flip the tool upside down, if you will, or some of our tools upside down to tell the story of speed, as opposed to thinking about where speeds are decreasing as a problem, right? That's what we want in this case. We want to see speeds dropping along this corridor in comparison to these countermeasures or these safety measures that have been implemented between March through July of 2023. So what I did is I ran the temporal comparison map tool on Fairfax County Parkway for March, July, and November. The really cool thing that the temporal comparison map does is it spatially analyzes each one of those months, and then it creates a delta map. And it shows you explicitly which what segments of road had a change, positive or negative, relative to whatever the performance measure is that you're looking at. So I want to look at March relative to November. I got to change my performance measure back to speed. Now take a close look at the delta map. Remember, this is March, July, November. My delta map is comparing March, the early phase of this campaign, versus November, which is essentially pretty well past the implementation of the campaign. My legend, again, is designed to look at where speeds have decreased. I'm going to configure the legend so that I want to focus on where speeds decrease. So I'm going to move this stuff around, and I'm just going to say, you know what? Anywhere where the speeds have decreased by any measure, more than 0 to 10 miles per hour, I'm going to change that color. But to also create this sense of transparency, so I can really highlight the difference, I'm changing all the other speeds to just white. It's kind of a cool way to just kind of look at the difference. Now then, right now, keep in mind, I'm looking at the difference between March and November for 12 to 5 a.m. Now look at the difference between 10 and midnight. Wow, they made that much of an impact. And I can interact with these, and I look at specifics to how much of a change has actually happened with regard to a decrease in speed. But what a cool way to use temporal comparison maps, right? To really look at things differently, as opposed to focusing on where's congestion gotten worse on our network. Use these tools to identify where countermeasures may be improved. Again, everything I've showed you thus far is looking at harmonic mean speeds against these roadway segments. If you really want to drill in the last couple of minutes I have with you, if you really want to drill in, I invite you to use the corridor speed bins tool to analyze all speed readings that occurred in the period of time that you analyze for the date range that you analyze, and it groups them in buckets. So what you're seeing here, that same roadway segment represented as a straight line linear diagram, westbound, eastbound. Check this out. I'm going to change my legend again in this quarter speed bin for, what am I looking at here? I'm looking at 10 to midnight, November, July. Let me switch this around. So I'm looking at March on the inside, July in the middle, and November. I'm going to just change this. Now I can look specifically at speeds exceeding 60 miles per hour. And I can evaluate what the improvements have been. You know, have they been significant? I can look at these speed bins in particular. It's measuring everything. You know, it's not doing any harmonic mean. With the corridor speed bins tool, you can really drill in and look at the specifics of the change from, well, here we go again, from beginning of the campaign to the end of the campaign. In some cases, there's been improvements. In other areas, there haven't been. I took the results of this, and I like to do compare and contrast in a geospatial context. So I took the results of this corridor speed bins tool. I mapped it out in an online GIS, in an online map app. We're looking at March right now. If we turn on July, we could see that there's been a decrease in the total number of hours. And then take a look at November, even less. So with that, I've got no more time left. I was going to close with just a conclusion, but I'll turn that turn the sharing back over.
Yeah, appreciate that, Rick. And like you said, we're moving right along. I think as people have some questions, they can go ahead and post that into the Q&A. But I think it's probably appropriate for us to hand this over to Bob and Michael to talk about the RITIS Enhancement Working Group.
Okay, I'll start off. Here we go. Actually, Michael, can you go back to the first one for a second? Just a couple quick introductory words. So most of you know, with our RITIS Product Enhancement Group, we've got a pooled fund from DOTs to help pay for all these upgrades and help the CATT lab decide where to focus their resources. We've got 5 DOTs that have contributed money so far. So thanks to Georgia, Virginia, Massachusetts, Oregon, and Michigan. We always want to keep this funding stream going. So DOTs can use different sources of money to contribute to the fund, including SPR. Other public agencies can contribute as well, not just DOTs. So if you can contribute, your agency can have a very influential say in which improvements get developed going forward. So if you're interested, talk to me or Michael, and hopefully we can get more contributions. Next slide. So some recently funded enhancements, ones that have been completed here. The API enhancements for INRIX XD segments. These APIs are for programmers and developers that don't need to use the RITIS interface because they already have their own tools and applications. That's complete. The business use case handbook. This is based on the handbook that Oregon DOT made. This is called the Best Practices in RITIS. You can now download this from the help menu. It's an interactive PDF document. It's an excellent resource with a lot of details on all the tools that are available with many use cases. So definitely check it out if you haven't seen that yet. We've done more reporting templates as well that they've been added to the variety that's already in the help section, like the bottlenecks, top bottlenecks, holiday travel forecast, after action reviews, and so forth. Mirrored directions, mirrored XD and TMC route selection. This is for INRIX segments. It allows the user to pick the endpoints of a road rather than just typing it in or searching it. And the mirroring means you can now automatically choose the opposing direction. The tool will do that. Downloadable volumes in the PDA suite, you can now choose from available volumes, whether it's INRIX or from your own DOT if you've supplied that to the CATT lab, or NPM RDS. And like Mark said earlier, the CATT lab always needs volume data for from each state, and annual volumes if possible. Weather data overlays, you can see the correlations between weather events and congestions now. They can be viewed together. And the automated work zone reporting, actually, let's talk about that on the next slide, Michael. So this reporting tool is still in progress. It's expensive. It's still not fully funded, but this has been the biggest priority of our working group. We've also had a design review group make suggestions to have the most common metrics automated. Some of these metrics now in the PDA suite, but that would be time consuming and somewhat cumbersome. So the idea behind this is that you can go to a work zone on a map. There'll be an icon that pops up for it. Then you can go in and define your work zone by the specific area you want to analyze. It can be just the zone itself or a larger corridor that includes the zone. Define the time period, hit submit, and then this tool will automatically populate a lot of the performance information by pulling different metrics directly from the PDA suite. Next slide. So this is a list of our next set of priorities that we started discussing at our meeting in December. I'm not going to read through all of it, but and you see that the work zone reporting tool is at the top of the list. You can see there's many options here that we're considering that cover a lot of different areas, like more delay metrics, more dashboards, safety information, freight, more functionality upgrades. And our group is evaluating all of them right now. So more on that at our next meeting, probably. And with that, I think I'll turn it over to Michael to talk about some of the other recent updates.
Thanks, Bob. Next. So as we wait to figure out all of the other things that we're going to be working on based on the enhancement group votes, we've been working on some other activities that have either been funded directly by specific DOTs or by a grant that we may have received from someone. One of those is enhancements to the crash safety analytics tools. So we get a lot of ATMS incident and event data from agencies, but some agencies are now giving us their police crash data sets. For those who are doing that, we've created some new dashboards that allow you to go in and query those crash data sets and view different results. Next slide, please. Basic mapping stuff, looking at injury events. Next slide, please. Another graphs, heat maps. Next slide, please. All sorts of different visualizations. Keep going. Next. So we still have a lot of work to do on those, but they have been deployed, and for the agencies that have given us your crash data, it's available now. If you have crash data that you want to have us ingest, please just write to me or write to support, and we will get your crash data in here so you can play around with as well. For the trip analytics tools that Greg Jordan went over as part of the LA wildfire stuff, we've made some new updates to allow you to upload various shaped zip files for your study areas and your spatial filters. Next slide. And then if you're drawing spatial filters within the tool itself, you can then export those as shape files for use in other tools or for saving it for later if you're interested in doing that. So that's relatively new. Next. For those of you who use the signal analytics tools within RITIS, you now have the ability to go and create these matrices that allow you to compare all the different turning movements at a particular intersection. So not just looking at one turning movement at a time, but looking at them all and seeing which ones are getting the greatest number of vehicle counts, which ones are experiencing more movements or control delay, or whatever metric you decide you want to put up on this. Next. Some things we're working on but are ready for prime time is some truck parking analytics. So from several different providers, we get granular enough data from trucks that we can literally see where they are parking. So this leftmost image, you can see trucks parking lining up right with where the actual parking spaces are. The blue dots are from the probe data providers, and it's overlaid on top of an actual truck rest stop. Over on the right-hand side of the screen, you're seeing the same general thing, but this particular truck stop is along a busy portion of I-95 in Maryland, and you're seeing dots where trucks are parking on the ramps leading up to the truck stop or on the ramps leaving the truck stop because there's just not enough parking spaces available. So we're working on building some analytics that are going to make it easier for agencies to be able to study where trucks are parking, when they're parking in particular areas, and are there places where trucks are parking in an unsafe manner that need to be dealt with. Next slide, please. We've also partnered with a company called Vision or Vision. They provide dash cam video from commercial vehicles. And what we want to do with this, next slide, please. I have some more. Yeah, what we want to do with this is build in almost like virtual CCTV cameras in RITIS. So this is a screenshot from the RITIS interface. The goal here would be to be able to click anywhere on the RITIS map, and then we will automatically go out and find all of the trucks that have driven past us within the last 5 or 10 minutes that had cameras, dash cams on them. And we will then allow you to play through and view the images that were taken from those trucks for use in just analyzing what's going on out there. Maybe you want to verify whether or not a work zone is operational. Maybe you saw a report of a Waze reported crash, and you want to verify whether or not there's actually something out there or not. So that's being built into the system. We're trying to work on that now. Next slide. Along with that, I think everyone has seen our congestion scans. This is a congestion scan. It shows you a diagram of the roadway and where the congestion is occurring, where the crashes are occurring. We also want to take the vision cameras and we want to be able to overlay that on top of these. You might have seen some folks from Purdue who've done something like this already. Go on to the next slide, please. So we'd essentially be able to overlay on the congestion scan the trajectory of the truck or trucks that were driving down the roadway, and then give you a little dot that shows you where the truck took pictures. Next slide, please. Keep going. And then you'd be able to interact with this and be able to put your mouse over individual locations, see what picture was taken at that location. And if there's a crash that's there, you might be able to identify, okay, well, there was a slowdown because of a crash, or there was a slowdown because of weather or something like that. Go to the next slide. I think I've just got a few more examples of this. Here's where you might have multiple trucks where you see the trajectories. Next slide, please. Being able to turn off the congestion and just look at the trajectories themselves. Next slide. Yeah, there you go. So those are some things that we're actively working on. We don't have a date in which we believe they're going to be ready for prime time and deployed yet, but they are in progress. Yes. So next slide. So that's the stuff we've been working on. There's more to come, as Bob mentioned, from the enhancement working group. With the few minutes remaining, this is where we ask you all to tell us what's working, what's not working in all the RITIS tools, and to tell us what you wish the functionality was that's not there right now. So give us your wish list of things. I think we have a poll that allows you to go in and type out your answers to this. Please take your time. We will leave this up after the webinar concludes officially at 12:30, so that you have enough time to go in and type your answers out. And you can also always email myself or email support@ritis.org with your wish list as well. Your wish list and your complaints. Things only get better if you tell us that they need to get better. Is that poll open? I'm not seeing it.
Yeah, it's open right now.
Okay.
Yeah,
Excellent. So take your time to answer the poll, and also if you have any remaining questions, throw them out. We can try to answer those too. And I'll pass it back over to you, Matt.
Well, I appreciate it, Michael. I think we're right here on time. We got about 2 minutes left, but like Michael said, that poll will stay open for folks to continue to provide their feedback. In addition to that, right, you can push that over to the side. If you have questions for Michael or for Bob about the enhancement working group, or any of the other panelists that we've had today, feel free to go ahead and put that into the Q&A. And again, to reiterate what was shared at the beginning of the meeting, this meeting was recorded. It'll be posted here usually in a few weeks after Joanna and Esther have had a chance to make sure it looks nice and clean and professional, the Q&A along with slides, so that you can come back and look at this at a later date. And Michael, I'll ask, since I have a question, for the truck parking data, who all have you all, for what you had right there, who are you working with, and which vendors do you think will be able to provide that type of data for us to pull into the system?
We're still exploring all the different vendors that are out there, but INRIX has data we believe that can work for this. There's Geotab as well, and there may be others.
Very good. Looking at the Q&A box. Appreciate the feedback from folks that have already shared it. Lots of great questions that have come in already. And with that, again, we'll leave this the survey open for a few more minutes, but we are at the top of the meeting. So again, thank you very much, everyone, for your attendance today. On the screen, you'll see a list of email addresses for you to go ahead and reach out with any questions that you may have, any feedback that you have along the way. We look forward to seeing you in May for our next quarterly meeting, and thank you very much. Have a great rest of your day and great rest of your week.